Hello guys, I'm ElfNet Gaming. I'm back with another video for you, radio communications. You notice I've been making more radio videos, and the reason for that is, well, that's what I do as a career job in communications and IT, and I figured I could try to share some education with those other people on my YouTube channel that watch me, that are rail fans and things like that. Some knowledge on some radio communications, because having a camera when rail fanning is just half of the thing. A lot of people like their police scanners, but what about on those days when you can't go out, it's bad weather? Well, that doesn't stop the trains, and you can listen to trains on one of these. This is an RTL SDR. This is a software defined radio with a Realtek chipset. It takes a USB input, and I'll free it from its plastic prison so you can get a better look at it. I'm not sure how they got it in this bag. It comes from China. I think I paid about 20 some odd dollars for it. There it is. It's got this graphic on it, this sticker, I guess is what that is, some kind of sticker, wrapped around a metal case about the size of a pack of cigarettes. It's got two antenna ports here for SMA. It's got a HF and a UV. Now, UV is UHF, VHF. If you're going to listen to your local police departments, weather stations, railroads, things like that, you want to go onto this port, this antenna port here. This is not to be confused with the antenna ports on your Wi-Fi connectors and routers. This is the other version that has the female inset. If you want to listen to amateur radio, shortwave broadcast, AM broadcast, things like that, you'll listen on HF port. That usually requires an outside antenna that is very long, or long wire. You may or may not have the means for that. If you live in an apartment, you might have to improvise a magnetic loop. There are videos on YouTube for that. On this side, we're taking in a little USB connector. It does come with a cord. There's an LED. It's an aluminum box. And this one came with this cellular phone type antenna. We have our little magnetic base. We have our SMA type connector. And we have our antenna. This is for the VHF, UHF. Well, mainly UHF, judging by this part. If this was a transmitting antenna, I would say 800-900 megahertz. But the rest of it, this looks a lot like it used to be an old cellular phone antenna from the 90s. Just saying. But anyway, it'll have its use probably in the VHF band or whatever. To go HF, and you don't have an HF antenna, you can take a long piece of wire, longer the better, and just wrap it around this. Put this on it maybe to hold it in place, and then connect it to the HF port. And I'm going to go to the computer and show you how this thing operates. I don't know how it operates. I just got it, just unbox it. I don't even know if it works. So we're going to go to the computer, and we're going to do some screen capturing with SDR Sharp or whatever other programs I can run up there, and we'll see what we can hear with this radio. Alright guys, I am on the computer now. I have the SDR, the new one, hooked up, and we're on the FM band. I'm hooked into the UV port, and to receive FM broadcasts, okay, you want to make sure you go into here, into this, the options menu in SDR Sharp, which for some reason isn't showing up on the recorder. I don't know why, but it's the one that looks like a gear. You click it, and you're going to go to sampling mode. You want the quadrature sampling if you're going to be using the UV port. If you're going to be using the HF port, then you're going to want the Q branch or I branch. It depends on your SDR, and that will allow you to tune below 24 megahertz. Okay. So with that, if you want to listen to radio stations, one, you're going to dial in a station you know. Like I know 98.9 FM is one here. You can see it on the waterfall. It's there. There's another one at 99.7. And there's some noise and stuff also from the computer. But your FM stations are going to look like these right here. You want to make sure that your bandwidth is at 250,000. You know, that is the max. That way it covers it all. I know that's not actually the USFM bandwidth, but it's good to have so you get it, you know, it doesn't have any chopping going on or anything. And you want WFM selected. And with that, your sound card and everything output should be whatever sound card, you know, that's in that section there. And again, that's not showing up, the list drop down's not showing up on OBS Studio for some reason. And then with that, if it's all hooked up right, you hit play, you should get your station, and that's Rob Zombie. Play. We'll go down to another station. Not a very strong station, but you can mouse wheel this and get your frequencies. Now you can also it's not limited to just this. Now this is operating off of the little antenna I showed you earlier, the little cellular phone looking thing. As a receiving antenna for this type of band, this is fine. There's enough metal there to do it. But I wouldn't be transmitting on this in any band by any means. It is receiving fairly well, seeing as I just got it laying here beside me. It's not actually elevated or anything like that. It's just laying on the desk here. So we're going to go up to a higher part of the band, 162.4, the local weather broadcast. Let's see what we get. Well, right off, I know that the bandwidth is not right.
The dew point was 73, making the relative humidity 62%. Winds were south at 21 miles an hour. The pressure was 29.68 inches and falling. And in downtown Shreveport.
And that's the weather band. That's in the VHF high band. The weather channels are 25 kilohertz apart from each other, so 162.4. The next one will be 425, 450, 475, 500, 525, and 550. There's 7 total in the US. You could put it in your SDR or even your police scanner if you have one, and one of those 7 should be able to be received by you. I don't know what frequencies are in Canada or Mexico or other countries. I'm sure they're similar in some fashion. You know, now, but just below 162 is the railroad band. It's listed as marine band here, but that's not right. I don't think there's anything really going on the railroad band right now. 161.1 I think is the KCS yard here, or it might be something else. The thing is that I'm not seeing any anything in the well, I'm seeing something there, but I don't know what that is. I don't see a whole lot here. $162,055 will be the rail yard, I think. They have a repeater. I'm trying to see if I can hear it, but I'm not hearing it here. I don't want it to squelch off either. there's a lot of signals and stuff happening, but a lot of those signals are just noise from just things. A lot of RF noise. Okay, anyway. So if you have this SDR and you want to go and monitor HF, the high frequency band, well, you need an antenna that will go into that port. You need some type of SMA type of deal that will go into that HF, or an adapter. You can use an adapter. I'm just going to try to use the little one I got, and I've got a long wire. I don't know what I did with it. But anyway, you're going to go back to your little cog up here, and where we got quadrature sampling, you're going to change it to, I'm going to start with the I branch first, because I'm not really sure which one this takes. They say Q, some take I. I'm going to start with the I, and I'm going to run this down to 6 meters. I'm going to keep running this down to medium wave. And I'm going to put it on a station I know is local in the AM broadcast band. So it's not the I branch. If you do that and you don't get anything on AM broadcast band or whatever frequency you know down low like that, change it to the Q branch, and try that. Still not getting anything. So what I might do is get a long wire going here. Hold on. I will cut the video. Alright guys, I'm back and I'm on SDR Sharp. I've got the new USB SDR hooked in, and it got a station dialed in, 710 kilohertz. I did check it before I started recording. This is AM on the AM dial. So yeah, that works. I don't want to play too much of this commercial stuff. Yeah, no. Sorry. Seems to be a lot of that going around.
So my source is good or not? I want to say true, but I mean, you can't.
Seems like there's a lot of church on today. It is Sunday. Alright, we're going to move up the band. 1.8, 160 meters. There's probably nothing on during the... No. Here's some shortwave. Though I don't think there's anything on here. This is all interference from the computer, all this. Yeah. So we're just going to run up the band. Now, shortwave during the day is going to be more in the higher bands. Yeah, interference. Things really get interesting here at 80 meters. This amateur radio. This is during the evening hours. This is a very popular band, especially on the latter end of this band, down on this end. It's worse than CB radio. Sometimes. This shortwave broadcast band is not bad. Of course, there's not going to be anything during the day here. There's all this IF interference from nearby radio systems and stuff going on. 4 megahertz. This is where you'll find a lot of maritime traffic, a lot of military traffic. For example, 4.724, an upper sideband. Zoom in. This is the U.S. Air Force Global HF. This is where they broadcast the EAMs, the emergency action messages, things like that. There's something going on there. What is that? That's a dead carrier. It looks like a dead carrier for a shortwave station. They're not actually broadcast. They just got a dead carrier. Huh. 5 megahertz solid. That's the atomic clock, a UVB atomic clock. One of them. They have 3 or 4. They got the one, I believe, is on 60 kilohertz. Then they have a 5 megahertz, 10 megahertz, 15. I think I have a 20. So we can go to 10. You can kind of hear it. They're even numbers. This is what atomic clocks pick up and set the time by, for the most part. 30 meters. Looks like something's going on there. Let's tune it down. Yeah. Get the bandwidth smaller. Crank the bandwidth down. That's what this slider, what I'm doing here, bandwidth. You don't want it wide. Actually, for Morse code, you want CW mode. So that's a ham operator Morse coding on 30 meters, which is about 10 megahertz. 10113 kilohertz or so. Probably 5 here. I need to set my offsets up. Here's another one. Here's one. There's one there. And if you listen long enough, you'll hear strong signals and you'll hear weak signals. They're talking back and forth in Morse code. And usually it's computers that do this stuff now. Or I'll go back down to 5. So 5 megahertz shortwave is dead. There's a 60 meters. Looks like it might be something small there, but right there. Can't tell. It could just be computer noise. A lot of it's going to be computer noise because, you know, reasons. Computer. There's the shortwave band for 6 megahertz. Looks like something's trying to kick up there. Can't really tell what that is, though. In the evenings, these lower frequencies will kick up overnight, and there's something there. What is that? Anything outside of ham radio bands will more or less be oh, it's WLO. This is a maritime beacon, one of them. I'm not sure which one this one is on 6316, if that's even right. It's probably 6315. I don't have my offset set up where, oh, the frequency correction offset set up properly, so it's off a little. Yeah, this is WLO. This is a beacon, and people on boats, mariners, can go into this system and send messages and communications back to shore to relay to phone lines, things like that. Or they can get information for weather reports, request weather facts, where they can actually get a fax sent to them at sea and print out a weather map, which I've received here at my place. Some of that stuff. Everyone, wave conditions, ocean currents, stuff. Just moving on down. This stuff here, 40 meters is an active band during the day. I know that. I'm gonna move it down, and then we'll go into it. This band is split into two parts. You have a CW part, which is Morse code. You can hear them. Just Morse coding away on Sunday. And they're just doing a CQ, just calling. And then the upper part of the band is a lower sideband for voice communications, but I don't really hear a whole lot of voice on 40 meter. I did yesterday. Well, there's some. Maybe we can't dial that in. That looks like a data mode. Yeah. It's a weight tone for somebody wanting to send data. Right. I'm trying to dial this guy in. It's hard to hear him. There's not a whole lot of voice traffic on 40. That's a shortwave. No, this is more. Oh, we got some pirates. It sounds like. Give it some more bandwidth. Yeah, these are amateur operators operating in a shortwave broadcast. According to SDR Sharp, this is this is shortwave broadcast, but I think this is all part of the ham band. There's also shortwave stations in here. It's the Wild Wild West HF. I'm not sure what that is, and I'm not going to stay there very long to give me a headache. That's a station. Shortwave station on 9350. Wow. Christianity. What's a religion when you can't backstab each other? Talk shit, you know. Justify it in God's name. That's why they're on shortwave. They can't get syndication anywhere else. The FCC won't allow them or whatever. There's a station. 30 meters seems to be active. Definitely a lot of Morse coding going on here. Look at this. This upper sideband, dude. It's trying to tell me, but it's not. It's CW. Now, there are programs you can use to decode this stuff. I'm not sure what this is. I think it's just intermod from something nearby. Fox News Radio. That's a shortwave station. The local station here, I think, has a shortwave. I'm not sure what this fucking noise is. Shortwave broadcast, 11 megahertz. That's, yeah. Ugh. And there are amateur radio operators that put on radio shows too. They'll have phone lines, you can call them, they'll have like shows. I've heard them down on 80 meters. It's interesting. Let's see, 20 meters seems to be, I gotta get past this whatever. There's a lot going on this band. Oh God. There's a lot going on here. It's during the middle of the day. Yeah. RTTY. There's data modes going. There are programs to decode data. These are probably just, these are text messages, things like that, just all the sort. Let's find this. That's Morse code. This is up all higher. That's data of some sort. I got programs to decode this stuff. Then we go up here. This looks like voice up here. It's a matter of getting past all of the crap. Like, for some reason there's spikes of something. It's not AM, is it? No. Upper? There he is. There he is. Lake County. I don't know what Lake County is. $20 meters is working. Give it a little more bandwidth. So yeah, it's safe to say that the HF section of this SDR is working. I mean, I could go on for a long time with this, but I don't want to waste any more time. This video is probably long enough. Yeah, I'm gonna leave it there. Overall thoughts on this box. It's pretty good. It's a lot better than the little dongle I had. It's got filtering in it. For about 30 bucks, you know, it's not bad. It's already built. Plugged it right in. Works. Yeah, anything else I have to say on this? Probably not. It works HF, works UHF, VHF, all the way up to, I think, 2 gigahertz or something. I don't ever go up that high. But yeah, that's what it is. I'm ElfNet Gaming, and this is my little review on the USB RTL SDR, the new one, the box, the HF version, and I will see you guys in the next video.